Hi guys, welcome to chapter 19, section A, and a little tiny bit of 20A as well. We're going to combine magnetism and electricity. Okay, so quick review on magnets. You know this, you've played with magnets enough as a kid that you kind of know a lot of this stuff. Magnets have poles, they have a north pole and a south pole. That's where our magnetic north pole and magnetic south pole comes from. Opposites attract, like poles repel. Okay. But all magnets emit what's known as a magnetic field. Okay, this is a field force, and so the magnetic force is kind of extending beyond the magnet. That's why you can hold magnets close, and once you get to a certain distance, the magnets will either push away from each other or they'll snap together because of the attraction. So that field goes beyond the magnet itself. And the Earth is just a gigantic magnet. It has a huge magnetic field around it that helps protect us from some of the dangerous stuff that comes from the sun. Okay. Electricity, charges of electrical particles also have a field. Talk about that a little bit. Let's talk about what these forces are first. So opposite charges attract, a positive charge and a negative charge attract, like charges repel. So very similar to magnets in that regard. Okay. The force is that kind of, attraction or repulsion between the two charged objects. Okay. The amount of charge affects the force. That should make sense. The more strongly something is charged, the more of effect it's going to have either on an oppositely charged particle or a similarly charged particle. So the more it's charged, the stronger that is. But then the distance also can affect that force and that field. Okay. The closer they get, just like magnets, the stronger that field is going to be. Okay. So this is what the electric fields look like. And it should look very similar, especially the opposite ones. These right here, it's similar to what magnets do. Okay. Just like magnets, this charge exerts a field. So it extends beyond just the particle itself. And then they interact with other charged particles and they create different fields accordingly. Okay. You can see that the two different charges will actually pull towards each other, and then the like charges are going away from each other. Notice the direction of the arrows though. So with a positively charged particle, the field is kind of drawn as going outward. With a negative, it's kind of going inward. Okay. It's just to show the opposite nature of those. Okay. Again, like charges repel, opposite charges attract. And the electrical charges really want to be balanced. Okay. They don't like being unbalanced. It causes funky things when that happens. However, electrons like to wander. And so we do get an unbalance of charges frequently. Sometimes we can pick up extra electrons, which is going to make something more negative, or sometimes particles can lose electrons, which make them more positive. That's kind of the nature of chemistry. That's how a lot of those chemical bonds occur, because of that movement of electrons, right? But we can also have something called static electricity that is a result of that movement of electricity. That is my nephew. Yes, he just slid down that slide and created all kinds of static electricity there. Okay. So as these objects gain or lose electrons, they become charged. If they gain electrons, they become negative. They lose electrons, they become positive. And the static electricity is the buildup of charges on an object. Okay. And it can be built up by friction, which is the picture here. And that's the most common way. When you walk across the room in your socks and then you get shocked when you turn the light on or touch somebody, that's static electricity that's been built up because of friction. Lightning is built up with friction. The water particles in the cloud, the air particles, updrafts and downdrafts, everything's rubbing up against each other. It's just a huge buildup of static electricity. Okay, so friction is the most common, but then there's also conduction, which is from objects touching. And so then the transfer of electrons is directly transferred through that direct contact, or induction, which is without contact. Okay. Static discharge, this is the fun stuff. This is the lightning that I just talked about. Okay. So static charges build up, but they don't flow. The next section we're going to talk about how electricity does flow. With static, it doesn't flow. It just makes this mismatch. Okay. The static discharge is rebalancing those charges. Okay, nature likes things to be even. It likes equilibrium. So the electrons will eventually have to move to rebalance them. If you have too much positive over here and too much negative, over here, eventually they're going to change places, okay? And that's a static spark. A huge static discharge is lightning, okay, from that friction that I talked to you about. In class, we're gonna play with static electricity, and I also have a video on just static electricity, some demonstrations that you can look at. Today is a fairly humid day, and so that actually decreases the static buildup. I wouldn't be able to do a lot of static demos for you guys today. So the more water vapor there is in the air, the more that hinders the buildup of the static imbalances. Okay. You notice in my classroom, I have this Van de Graaff generator. It's the big silver dome-shaped thing in the classroom, and it creates static through friction. Okay, there's a rubber belt inside of it, and there's a crank attached to it. When I turn the crank, that belt moves. There's like a little comb, like a plastic comb on it, that's rubbing on the belt. That's friction. Okay, so the charges are built up. Positive charges collect on the dome. And then I have this little wand that I bring close to it. The wand is plugged in down here, and so it has a negative buildup. Okay, when they get close enough, a little mini lightning bolt zaps between the two of them. A static discharge takes place, and it's the rebalancing of those charges. Okay, not going to do that today for you because it's too humid. But look at my video on the static demos, and I will do those in class for you as well. All right, that's all.